In this video, we're going to be evaluating radical expressions. Now, once again, you'll want a power table somewhere nearby because we'll be using this later on in the video. So, what is a radical expression? Radical expressions consist of an index, a number that goes in the top left-hand corner here, and a radicand, or what I'm going to refer to as a base, the number underneath. And we usually note a radical expression with this radical expression bar over top of the base. Now, what do these things represent? What do they mean? That's what we'll be looking at in example 1 here. So in number 1, I'm taking the third root of 8. Okay, this index number, it's a 3, and we call it the root of the expression. So we're taking the third root of 8. Now, what it means, what this 3 is asking us, is it's asking us what number, okay, so if I have some number and I multiply it by itself 3 times, okay, that's why it's a 3. It's asking me some number that I can put in this box, that when I multiply that same number to itself, I should get the number underneath. It should be equal to 8. If you think about it for a little bit, you should hopefully realize that the number 2, that if you take 2 and you multiply it by itself 3 times, or in other words, take 2 to the third, you should get 8. Well, 2 times 2 is 4, times 2 is 8. So 2 to the third is 8. So the third root of 8, we would say, is 2. So we're looking for this number that when we take it to that power, we should get the number underneath. So 2 to the third is 8. All right, similarly, if I look at example 2 here, I want the third root of 27. So I want to know what number, when taken to the third power, will give me a 27. Well, that number is 3, right? If I take 3 to the third, that would be 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So this number I'm looking for is 3. So 3 is the third root of 27. Now, as we move on, the numbers will start to get bigger, and that is where your power table will come in handy. So this next example, we're going to use the power table to help us. So here we have the fourth root of 81. So we're looking for some number, okay, that when we take it to the fourth power should equal 81. So to do this, on your power tables, we're taking the fourth root. So we know we're dealing with the fourth power. So I go to the fourth power, I scroll down to where it says 81, and I look to see what number gives me an 81. It's 3. So this answer, the fourth root of 81, must be 3, which means 3 to the fourth is 81. Okay, so my answer here is 3. Now, in example 4, you'll notice that the index is missing. There is no number written here as the index. In math, we call these square roots. Anytime the index is not written, we assume that the number there is actually a 2. So we're looking for some number that when we square it, okay, when we take it to the second power, we get 16. Well, what number, when you multiply it by itself, okay, when you take a number times itself, what number equals 16? Well, that number is 4, right? When I take 4 times 4, I get 16. So the square root of 16 is 4. Now, like I said, you can see this on the power table as well. We want the second power. We want to scroll down to where it says 16, and we see that the second power of 16 is 4. All right, let's look at some bigger numbers here so we can get an idea of why this power table helps us. So let's say we look at number 5. Here I want to find the fourth root of 1,296. Now, I likely don't know this one in my head. I don't know which number that when it's taken to the fourth power is going to give me the base underneath. So instead I rely on my power table. I'm going to go to the fourth power. Sorry, here I'm trying to find the best way to show you. Okay, so I'm going to go to the fourth power. I'm going to scroll down to where it says 1,296. Okay, so fourth power 1,296, and it tells me that number is 6. So I know the fourth root of 1,296 is the number 6. All right, let's go ahead and try number 6 here. I got the seventh root of 78,125. So once again, I'm going to the seventh root of 78,125, and I'm going to look to see that number is 5. So this answer would be 5. Now, remember, one thing I want to highlight here is what it means to be the seventh root. That means that when I take 5 to the seventh power, that should equal 78,125. That's a way I can check my work. So if I wanted to check my answer over here, I would take 6 to the fourth power, and that should equal 1,296. Okay, so you can check your work on these. Now, the last thing I want to talk about in this video is what happens when the base is negative. Okay, so here I have two negative bases. In this one, we have the fourth root of a negative 16. Now, if we think about this, if I take a negative number, okay, and I multiply it by another negative number, and then I multiply that by a negative number, and then I multiply it by one more negative number, right? I'm doing this 4 times. When I take a negative times a negative, well, a negative times a negative becomes positive. So these two will lead to a positive number. Likewise, when I multiply these two together, I'll get a positive number. And then when I take a positive times a positive, I get a positive. So any number that I were to put in here cannot lead to a negative 16. The outcome has to be positive because I'm multiplying an even number of negatives. So this actually has no real solution. You cannot get a negative base or a negative radicand when you take something to the fourth power because the negatives will cancel out and become positives. That is not true when the index is odd. Okay, so this thing that I just talked about only happens when the 4 or the index number is even. So if you're dealing with fourth roots, if you're dealing with square roots or sixth roots or eighth roots, anything that's an even number, if the base is negative, there's going to be no real solutions because you'll always get a positive. When it's odd, you'll actually get an answer. We'll see that in a second. If I take a number, okay, and I multiply it by itself 3 times, okay, and I want to get a negative 8, well, the answer would just be negative 2. The reason why negative 2 works is because if I take negative 2 times negative 2 times negative 2, well, negative times negative becomes positive 4. And then when I multiply by negative 2, positive 4 times negative 2 would give me negative 8. So I can get the negative base. Okay, so when it's odd, you do get an answer. When it's even index, you don't. You get no real solutions. Okay, so it's important to notice the difference there that odd ones will get an answer, even ones will lead to no real solution.